In order to look at the transient decay current in an inductor, let's assume this situation where switch A in this circuit was closed and switch B was open for a while. So the current through this inductor is, this is L. So I was the steady state current because it was closed for a while, A. So current is U over I, as we saw in the last video. Now at t is equal to 0, switch A is opened while switch B is closed. So the current in the inductor, through the inductor, will not stop immediately. It will decay. Since the inductor doesn't allow to change the current instantaneously, the current will go through it for a while and then it will decay. So if the current is I still, this way now, so if we write the KVL here, it will be, this is the voltage drop across the resistor and this is the voltage drop across the inductor, and if I solve this equation, it will become E over R e to the power minus TR L. So again, this one is, the time constant tau is the same because it's the same resistor R here. It's going through there, R, the resistance is R. So the current initially was, steady state current was like that, it built up like that, and this is somewhere when t is 0, when the switch A was opened and switch B was closed. At that point the current will continue like that, and it will slowly afterwards it will decay like that, but just t minus 0 and t, let's say t0 plus and t0 minus, the current is still the same, which is E over R. It's not changing instantaneously, but after a while, after then it will start decaying, and the time constant, the way it will decay, will be dependent again by this L over R ratio. So if L is large compared to R, it will decay slowly, and otherwise it will decay fast. So it's pretty similar that t at t is equal to 0, I is E over R, and t is equal to infinity, I is 0. Essentially it has to be 0 because there is no voltage source. So there will be a transient current which will be decayed with this time constant.